Okay, so here we start with some definition questions. Explain what you understand by a statistic and explain what you understand by a sampling distribution. So these are very much questions that we should have a stock answer to every single time. A statistic is a function that is calculated solely from the sample observations, making sure not to contain any population parameters or any unknown parameters, if you like. So a sampling distribution is all the possible values that a statistic may take and their associated probabilities. And these are usually arranged as a probability distribution of that statistic. There are many variations on how you can respond to these definition questions, so learn them off by heart and make sure you can get them down in the exam. Okay, moving on. A factory stores screws in packets. A small packet contains 100 screws and a large packet contains 200 screws. The factory keeps small and large packets in a ratio of 4 to 3 respectively. Find the mean and the variance of the number of screws in the packets stored at the factory. Okay, immediately here I want to arrange this information into a table. Let's first highlight what was important. So there's small packets which contain 100 screws. Small packets, 100 screws. Larger packets, 200 screws. The factory keeps small and large packets in a ratio 4 to 3. Okay. Let's go ahead and put these into a table, with X being the number of screws within a packet, and here we have the probability of picking a packet of that size. So, in a small packet there are 100, in a larger packet there are 200. We were told that the ratio was 4 to 3, so we instantly know the fractions and therefore the probabilities. So, the probability of getting a small packet is 4 out of 7, while as the large packet is 3 out of 7. Now that we've arranged in this table, straight away we should be thinking back to S1 and discrete random variables and how we find the expectation and how we find the variance. So the expectation of X is the sum of each X value multiplied by its associated probability. So in this case, we're going to have 100 times 4 over 7 and 200 multiplied by 3 over 7. Into the calculators, and we should get 1000 over 7. And I should also be able to find the expectation of X squared, which is the sum of each of the X values squared and multiplied by their probability, which in this case is going to be 100 squared times 4 over 7 plus 200 squared 3 over 7. Into the calculators, and we get an answer of 160,000 all over 7. Okay, and these two are connected through our variance formula, like we saw earlier. So the variance, E of X squared minus the E of X squared. And in this case, we're substituting quite large values, 160,000 over 7 minus 1,000 over 7 all squared, giving us a final answer 120,000 over 49, and keeping it as a fraction maintains all of our accuracy. And moving on, A random sample of 3 packets is taken from the factory, Y1, Y2, Y3. Denote the number of screws in each of these packets. List all the possible samples. Okay, fantastic. I was waiting for this. All the possible samples. So the size is either 100 or 200. So let's start with all of the sizes being the same. So that will be 100, 100, 100. Or 200, 200, 200. Okay, trying to stay systematic. Now let's see if 2 sizes are the same. I'll start with 2 100s and a 200. There will be 3 ways that this can happen, with the 200 at the end, in the middle, and at the start. I have been asked to list all of them, so I'll write these all out. Okay, what about if the 2 repeated same size were 200s? Using the section above as a little bit of a guide for myself. Okay, so I've done 3 100s. I've done a set where there's 2 100s. Can I do a set where there's only 1 100? Being really careful to notice that actually I already have all of the samples, all of the outcomes where there is only 1 100, and they're right down here. So I've got when there's 3 of a particular value, when there's 2 of a particular value, when there's 1 of a particular value, and when there's none of a particular value. So these should be all of the samples. Okay, and here's where we're going. Find the sampling distribution of Y bar. All right, so there I know that it's the mean. I already have all of the possible samples from the previous part of the question. I'm going to go ahead and find all of the possible probabilities, all of the matching mean values, and then combine them into the sampling distribution. So the probability that I have 100, 100, and 100 is going to be 4 over 7 times 4 over 7 times 4 over 7, 4 over 7 cubed. Probability I have 200, 200, and 200, 3 over 7 cubed. Okay, the probability that I have 2 100s and a 200, each of these are going to have exactly the same probability, and that's 4 over 7 twice, so that's 4 over 7 squared, multiplied by 3 over 7. I'm also anticipating that all of these are going to have the same mean, so right now I'm going to apply a multiply by 3. A similar situation is going to happen here, so I'm going to have 3 times 3 over 7 squared multiplied by 4 over 7. Okay, so I know all of the probabilities that are associated with. So now that I know all of the probabilities that are associated with these different samples, I'm going to go ahead and group them together. Firstly, do I know what the mean of each of these samples will be? I'll find it easier to put the means over here on the left-hand side. So the mean here is going to be 100. The mean here, 200. The mean here, just on the calculator, all of them will have a mean of 400 over 3, and all of these will have a mean of 500 over 3. So 4 possible mean values. So here was the Y bar, here were the samples, and here were the probabilities. Okay, so there are only 4 possible values y bar can take. So let's put that all into a sensible sampling distribution. Okay, so here's our table with each of the means and the probability that x equals the mean and the 4 possible means. So all that's left now is to find the exact probabilities of each of those happening. So the probability that the mean equals 100. If we work that out on our calculator, we get 64 over 343. So that was 4 over 7 cubed. Probability of a mean of 400 over 3. That's 3 times 4 over 7 squared times 3 over 7. That leaves us with 144 over 343. The probability we get a mean of 500 over 3. That's the bottom calculation. 3 times 3 over 7 squared times 4 over 7. That will lead to 108 over 343. And finally, the mean for the probability for a mean of 200 is 3 over 7 cubed. We could have done a 1 minus, but in this case, I had found all the probabilities already. 27 over 343. And just to be sure, I'm going to add each of those probabilities together. You can do this as well. Do we get an answer of 1? If we do, that is our valid sampling distribution for y bar, and that will be worth all of the marks.